factorization of a given number. So this is code to do that. It has to do with the fundamental theorem of arithmetic, which is described here. FTA basically says that for any integer greater than or equal to, it's either a prime itself or is a product of a unique combination of prime numbers. So n equals p1 to the alpha 1, p2 to the alpha 2, and pi to alpha I dot. And this is a unique expression of the number n. So how do we get the factorization of that n number? So this is the code to do that. Read in n, see out n, and check whether we are getting the first factor or not. If it's the first factor, it's true. You loop through n to n, I to n, from 2 to n. A is exponent of the number, so you keep dividing n by this I and add to the exponent if a is greater than 0. We count, we express it out, okay? Only if it's not the first factor number, we output the star, which is the multiplication symbol, and then set the first to false. And then we output I is I to the power of A, and then we output n y. So this can be used to get also the number of factors of a number. Also, it can be used to count how many numbers is co-prime with n, which is related to Euler's totient function, also called Euler's pi phi function. It's described here. The phi function, it counts the number of positive integers less than n that are co-prime to n. So this is a code that can give us that information. So the way we do that is by doing it here. So we get 1024, which is 2 to the power 10, and 20, which is 2 to the power 2 times 5 to the power n. 2048, and 1, 2, 3, 4, 5, 6, which is 2 to the power 6 times 3 to the power 1 times 643 to the power 1. So that gives the expression of the number n in terms of the prime number factorization.